Hey everybody, hope you had a great vacation. Well, not much vacation. Mr. LaChance here, just getting into the routine of school. Hopefully you get your project turned in because some of you have not yet. And other than that, we've got some things we need to do here to finish things up. We're starting Module 2, Topic 4. The first section, 2.4.1, is just loaded with a whole bunch of things that we need to talk about. So I'm going to go right to the notes with that. Missed you guys. Hope you're all doing well. So let me go to the notes. Okay, we've got them right here. I started them. We're going to be finding shapes. We're going to be doing roots. We're going to be talking about distance formula, midpoint. We've got a lot of things in here. So the first thing here is simplifying square roots. Now you remember perfect roots: 4, 9, 16, 25, 36, 49, 64, 81, 100, etc. You know, because the root of 4 is 2, the root of 9 is 3, the root of 16 is 4, and so on. So if it's perfect, we're lucky. Like the root of 36, you can see I wrote a 6 down. That's because I knew even if I put it in my calculator that it was an exact 6. If I put the root of 20 in the calculator, I get a decimal, 4.47. That's considered an approximate answer. You're going to need to know this for math too. You're also going to need the simplified root form. Now, what I like to do is I just like to divide 20 by all the numbers that go into it. So I would start with 1, and then 2, and then 3, and then 4, and then 5, and then 6, and continue until I'm finished. Don't want to use 1 because it's just going to be 1 and 20. But if I take the number 2, I know that 2 times 10 is 20. 3 doesn't work. I know 4 and 5 work. 6 doesn't, 7 doesn't, so that puts us back to where we were. Now what you want to do is you want to look for the pair that has the biggest perfect square root in it. Well, 2 and 10, neither one of them are perfect, so I can get rid of that. But I notice here I've got a root of 4. That's a perfect square root. We know the root of 4 is just plain old 2. Tack on the root of 5, and we're left with the simplified answer of 2 root 5. It's actually not difficult. Everybody makes this so hard, and it's really very easy. So if you take a look at 48 you can do in your calculator. But if we also need a root answer, I'm going to divide it by 2. 24 goes in. 3 and 16 work. 4 and 12 work. 5 doesn't work. 6 works. 6 and 8. 7 doesn't work, and you get to 8, you're back to 6. So now, get rid of the ones that aren't perfect squares at all. While 2 and 24 are not perfect roots, 6 and 8 are not perfect roots, meaning I can't root one of them and get a nice plain number. But I can with the 3 and 16 and the 4 and the 12. So both of those could work. Now I want to pick the biggest perfect square root. Well, obviously, I'm looking at the 4 here as a perfect root and 16 here. Which one's bigger? Obviously, the 16. So this pair's out of the question. Okay, I mean, it's literally almost a trial and error. Now, you should know that the root of 16 is 4. Finish the answer by writing the plain number first, 4, and the root after, and the root of 48 is really 4 root 3. So it's pretty simple on how you want to do simplification of roots. Good. You know me with this. Now remember here, Parallel slopes are lines that have equal slopes. Perpendiculars are opposite reciprocals. Okay, you can refer back to this little spot here in case you need to remember it for when you're doing something with the coordinate plane. Okay? Now, the distance formula. What's distance? Well, distance is basically the positive measure of something between 2 points, basically. So when you're looking at the formula, you basically want to take two ordered pairs and subtract, almost like slope, x2 minus x1, but you square it. Then add on the y2 minus the y1, and then square that. Okay, it doesn't really matter what order you use the x1 and y1 or the x2 and y2 because the square works it out. Just make sure you have the x's and the y's in the right spot. So if you take a look, here's a problem that we could find the distance between. Now here's my x1, here's my y1, here's my x2, here's my y2. So if I'm going to actually do this, draw my root. Okay, I know I've got x2, which is 3, minus x1, which is negative 2, squared, plus y2, which is negative 1, minus y1, which is 5, and square that. And you can put that right in the calculator. Okay, it will go right in the calculator. We'll end up with the square root of 25 and 36 is the square root of 61. Okay, now again, I didn't do the root part in the calculator. I just did 3 minus negative 2, which I know is 5. That squared is 25. And then negative 1 minus 5 is negative 6 squared is 36. Add the two together and you get 61. And you're lucky on this one because this doesn't simplify. Nothing goes into the root of 61. So all you would do then is put the calculator answer and the root of 61 is 7.81, usually round to the nearest hundredth. Okay? Distance is easy. Just fill in the formula. Same with midpoint. Midpoint, the idea, what is midpoint? It's the middle of something. Okay, usually between 2 points. And there's a formula for this. Okay, it's x1 plus x2 all over 2, comma, y1 plus y2 all over 2, parenthesis. Remember, it's a point, midpoint. So it's going to be an x comma y. So if I take these numbers here, again, literally set it up, there's my 2, comma, I always do this when I do these. Here's my x1, y1, my x2, y2. Plug in my numbers. Okay, x1 is negative 2 plus the x2, which is 4. Sorry, I got a glare. And my ink isn't changing properly. Plus, try that again, and now x2 is 4. And then y1 plus y2, y1 is 5. plus y2 is -1. And now I filled it in, and now I just answer it. Can do it on the calculator. -2 plus 4 is 2 over 2. 5 plus -1 is 4 over 2. Simplify, 2 divided by 2 is 1, 4 divided by 2 is 2, and there's your midpoint. So that's pretty simple also. I'm trying to see if I can pause this. No. All right, so next is the Pythagorean theorem. And the Pythagorean theorem, I don't know if you guys learned it, is simply in a right triangle, the hypotenuse squared equals a leg squared plus a leg squared. You can see here in a right triangle, the side across from the 90, or the long side, is the hypotenuse, and then the other two are legs. Okay? The actual Pythagorean theorem itself is c squared equals a squared plus b squared. Again, c being the hypotenuse, and then a or b being either leg. Okay? So, if we're trying to find the missing side, using the Pythagorean theorem, you'll notice this first one is a right triangle. So, this is what I need here. Well, that's my hypotenuse, so that's my c. And that's going to equal one leg plus another leg, both of them squared. Continue writing this, you get 49 plus 25, x squared equals 74. And now when you see a root, a squared, I mean, you always root it. And in this case, then, x will be, we don't want plus or minus because a negative can't be a side. The root of 74, give me a second, I'm doing it on the calculator, is 8.6. Now, you also might need to do that in simplified roots. Okay, simplified roots, again, is where we take the 74 and break it down. Okay, unfortunately, this one divides by 2, 37. So guess what? This is actually already finished. It's already simplified. You can't go any further. If it divides in its prime, it's done. Plus, honestly, 74 does not divide by 4, so that doesn't work. Certainly doesn't divide by, oh, if I even divide it by 6, that's a decimal. 8, 9, if I divide by 9, that doesn't even work. So actually the root of 74 is already done for you. So you got lucky on that one. This one here, now you'll notice you're given the hypotenuse, you need to find the leg. So here we would have something like 14 squared equals 9 squared plus x squared. Okay? You'd have to figure out what 14 squared is. 14 squared is 156 on the calculator. Gonna double check. Oh my God, it's 196. Oops, I knew my math was off on that one. It didn't even look right. 196. 9 squared is 81. Now this one's a pain because you actually have to solve for the x squared, so you have to subtract the 81. And you get 115. Okay, that's not, whoops, I made a mistake already. 196 minus 81. Yep, 115. Now go ahead and root both sides, and x ends up being, Second x squared is where it is on your calculator. It's in Desmos. 10.72. And the root of 115, I don't think that one simplifies. You divide it by 5, you get 23. So it's already done already. That proves to you that it's a perfect, that it's actually prime. So it's done. There's nothing you could do to that. So that's your examples of the Pythagorean theorem. Now, what I did below here, number 1, is to plot the points and find the distance. Then plot them and do Pythagorean. I'd like you to try that. Number 2 does the same. 3 and 4 is distance. 1 and 2 again is midpoint. These are finding the midpoint, where you actually have to do the ordered pairs and then do the midpoint formula. And then this Coach Alvarado with his football team did the distance in the midpoint. And that actually would be the stop for our first day of notes. I hope that helps. It's going to take a while to upload. Hopefully you'll get this upload and things will be good. Talk to you tomorrow.